All right, so I can talk. Sort the polynomials into two categories based on their form, factored versus non-factored. All right, this one was a little interesting. I want to make sure you understand. We're reviewing, by the way, factored versus non-factored. All right, is this factored out? No, okay. These could still be factored, right? This one is, that's an answer. We can have an answer look like this. This is factored. This is factored. All right. I'm giving you some help with this one. Is this factored? No, you could still factor that out. Is this factored out? Interesting. It actually is. There's two parentheses there. They're just the same. Now this one, you could still factor out an x, remember? GCF, and this one also is not factored yet. So little help there for what's going on. Remember, you can actually solve these and get parentheses. Your factored form will always look like they're in parentheses. So that's basically what your clue is for which one's factored and which one's not. Now, remember, this is your class assignment. I'm out today because of my, I have to go to a funeral. So just do the best you can on each slide, please. All right, this one's interesting. To factor, it is helpful to look for a greatest common factor first. Select all the polynomials below that have a greatest common factor greater than 1, which means which ones can you actually pull something out of that they both have in common. Remember this. Remember, it could be a number. Like this one, they both have 2 in common you could take out, right? This one, no, not so much. What about here? Do they have anything in common? Yeah, they have an x and a y. Anything in common? Yes, this can be factored. Anything in common here that you can pull out? All 3 of them have to have it in common. Interesting. All 3 here? Yes. Okay. So make sure you understand that. If you needed help, it's going to be here, 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 and here. All right. It's not telling you to actually factor them, but you could pull something out if you had to. All right. These ones. Factor the given polynomials by factoring out their GCF. You got to pull out the GCF and then factor. Ooh, this is fun. All right, where do you see answers here? So you know what's one way you could actually do this? That's actually kind of a cheat code. Let me help you. If you have parentheses like this, you can distribute. So this would be 4x times x would be 4x squared. 4x times 3 would be 12x. So where's 4x squared and 12x? Let me move this up here. 4x squared and 12x. Am I missing this? Oh, do they have a GCF here? Yes, there's a GCF. Where is it? Did I mess up here? Oh, it's right here. My bad. It's right there in front of me. All right, so there's my answer for this one. Okay. This one would be 4xy and 16. All right. 4xy and 16. Y. Don't forget the y. Do you see if I was to multiply that? All right, so GCF some of these. This you could pull out. What could you pull out of here? Actually, this one has nothing, no GCF. Do you see why this is no GCF? Because 2x squared, 8x, those two have something in common, 2 and x, but 9, they all have to have it in common, remember? They all have to have it in common. This one, what do they have in common? Do they all have an x? No. Do they all have a y? No. Is 2. Can you divide 2 out of all 3 of these terms? Yes. So 2 is your answer for this one. And believe it or not, it's going to be combined with this, right? 2, if I take it out, I'll have x left. 2 out of the 8x, 2 out of half of 2, or half of 4, I mean. Half of 8, I mean, is 4, and then half of 10 is 5, okay? Do the best you can with the rest of this screen, all right? It seems like a lot. Just take your time. Rewind what I've done if you need to. Totally fine if you need to do that. You can just go back 10 seconds or 20 seconds with the YouTube. That's fine. All right, polynomials with 3 terms are called trinomials. There are many different techniques to factor a trinomial, so use your favorite. Remember, it'll be helpful to factor out a greatest common factor first, if possible. Select the trinomials below who only have a GCF of 1. So you're selecting below which ones are already factored out that you can't factor anymore. And actually, this slide's not that. This one's already done, right? This one you can factor out. This one you can factor out an x, so that doesn't work. You could take an x out, right? This one, you can't take anything out. That one's done. This one, you could take a 2 out. This one, you could take a 3 out, okay? Understand what it means to GCF. All 3 terms have to be able to be divided. This could divide 3. out of all three terms. You can divide 2 out of all three of these terms, okay? All right, now factor the given trinomials so GCF equals 1. All right, so you're going to factor these out. You guys can do this. No big deal. Remember, you're going to do X games. If you'd like, I would put the trinomials on top to organize your work a little easier. All right, and then go ahead and find out which answers are where. I'm not going to do the work for you. You got this, okay? Oops. I guess you can click on it and make it bigger. That's cool. All right, factor the GCFs that are greater than 1. Again, put the trinomials up top. These might get a little crazy. Take your time. Understand, looking at my answers, interesting. Look at my answers. They all have a common GCF taken out of it, right? Do you see? The GCFs were taken out of it. Cool. All right, keep it going. All right, polynomials in the form of difference of squares can be factored as a squared minus b squared. All right, we talked about difference of squares. I don't know if you remember. Select all of the following polynomials below that are in the form of difference of squares. All right, so remember, both have to be a square root. So if you can square root it, and they can actually become a difference of squares. First of all, this is an addition sign. No way is this an answer. But what about the rest of these? To be honest, this x squared can be square rooted to be x. 9 can be square rooted to equal 3, remember? So they have to be both be able to be perfect squares. That's a great way to say it. 4x squared, if you square rooted that, isn't it 2x times 2x? That's a perfect square, right? 44 is a perfect square. So this would be 1. This would be 1. That would not be 1. This would be 1 because 3a minus b. 3a minus b, 3a plus b. This one, 100 is a perfect square. A, though, hold up. This is actually not going to work because you can't square root. That a has to be squared for this to work. If you square root the whole thing, it would have to give you an actual answer. What times what equals 100a? You can't multiply the same thing. You could do 10 times 10, but a times a, remember, is a squared. So this one does not work. This one does work. 4 and a. Okay, a little confusing. Factor the given polynomials using difference of squares. All right, so this one's a little tricky. I may, real quick, show you a couple of these I want you to get me the answers or the questions on top. I may do a couple of these right now. All right, cannot be factored, we'll put over here. And let me see if I can fit one more in here. And we're going to talk about these real quick. And what else? I have one more down here. We can bring that down here too. I'm going to do some of these so you guys get a sense of what's going on here. These are confusing. I get it. Don't worry. All right, so I'm going to go to this screen where I'm going to be able to write out some answers with my stylus here. The idea of difference of squares, if you square root, and let me make that a little cleaner. If you square root both sides, and you notice they're both perfect squares, what times what equals 4x squared? The same thing, remember? So it'd have to be 2x. That makes sense, right? 2x times 2x, doesn't that equal 4x squared? And then remember, it's going to be minus, what is that, 36? It's going to be 6. But remember, with difference of squares, we talked about this. And this is a good time to review it. Actually, I'm really glad we did this lesson today. You don't really need me with you, even though I have a video here for you. It's going to be 2x minus 6. Remember, 2x plus 6. Believe it or not, if you were to go ahead and multiply these two binomials, you're going to get this answer, okay? This is how the pattern looks. It's always going to be plus or minus, plus and minus, plus and minus. And do you see your answer here? Boom. All right, so that one does work. It ends up working. All right, let's do another one. All right, this one. Hello, that's a plus. Get out of here. Guess what? This cannot be factored. So you're going to drag that guy over here. Cannot be factored. All right, but we're going to do this one over here. Square root both sides. Square root. 3 plus 5x. Why is it 5x? Because 5x times 5x equals 25x squared. And not only 3 plus, but 3 minus. Okay? And that is going to be Hold up. Did they mess up on this one? No, they did not. No, it's over here. All right, it was a little tricky because I saw this one over here, and I thought that was the answer. But no, this is 3 plus 5x, 3 minus 5x. Okay? Do the best you can on this slide. It's kind of tough, I know, but do the best you can. And the last slide, mixed practice. Match the following polynomials with their factored form. All right, so you got to take your time. Remember, I would put more of the questions on the top and the factors down below. All right, so my questions on the top here, and my answers on the bottom. Oops, that's a factored form. My questions go on the top. Take your time. If you need your notebook out, that's fine. Go ahead and use it. But you're going to put these. This is 2. Yep. Hold on. Oop, I got another one here. And then try to go ahead and organize your work. These are all your answers too. Okay. Do the best you can with this one. No worries. And then when you finish, I can see that you've done all the slides. That's going to be your assignment for the day. Good job, Hudson.